Section 8.4 The Moivre's theorem, powers and roots of complex number. The Moivre's theorem. If you have a complex number and you can state in the trigonometric form or the polar form, r cosine theta plus I sine theta, and if we let n is any real number, then if we want to find out this complex number to the nth root, what we're gonna do? We could apply the De Moivre's theorem. First, the n you could distribute to the r, so r to the power of n. And how about this guy? You can just distribute the n to the theta, so you do have a cosine n theta plus I sine n theta. This is called the De Moivre's theorem. In the complex form, we can write it as r to the power of n times cis n theta. You could apply the De Moivre's theorem when you have the trigonometric form. How about if we do have the rectangular form? If you have the complex number in the rectangular form, what you're gonna do? You have to distribute it one by one using the Theorem method. Okay, I have a x plus yi to the power of n. So I have to multiply it like one by one. You do have an n times of it. Okay, so for example, if I have a x plus yi square, so I'm gonna use the Theorem method, distribute it one by one. Okay, to get your final answer. However, if you could convert your rectangular form into the trigonometric form, so we have x plus yi to the power of n. We're gonna convert it just like the previous session. I'm gonna get cosine theta plus I sine theta. Okay, then I could just apply the De Moivre's theorem. Distribute it, so that will become cosine n theta plus I sine n theta. Okay, that will be a lot easier. Example 1. Find this complex number to the power of 8 and express the result in the rectangular form. So the final answer, it has to go back to the x plus yi. So what we're gonna do first, we're gonna write this complex number into trigonometric form. So first, we're gonna find out what is your r, what is the modulus. So your x is equal to 1, your y, that will be equal to square root of 3. So plug it in. You do have a 1 plus 3, which is gonna be square root of 4. So that's equal to 2. Now, we're gonna find the argument, the theta. So tangent theta equal to y over x, which is square root 3 over 1. And 1 and square root 3, this is gonna be in quadrant 1, okay? So we find out the angle, that will be 60 degrees. And the argument will be 60 degrees. Then my complex number will become the r, which is going to be 2 cosine theta 60 degrees plus I sine 60 degrees. Now, we want to find it out, this guy to the power of 8. So after we change to the trigonometric form, we could apply the De Moivre's theorems. Okay? We're gonna distribute the 8, so 2 to the power of 8. And then the x is gonna be multiplied the theta. So cosine 8 times 60 plus I sine 8 times 60. So 2 to the power of 8, that will be 256. And that will be 8 times 60. And that will be 8 times 60, which is 480 degrees. So this is good, right? Okay, let me write one more step. 480 and 120 degrees are coterminal. it means I just subtract 360 for both of them. So you're gonna get 120 here. Since they request the result has to be rectangular form, so I'm gonna change the trigonometric form into the rectangular form. So what is a cosine 120? The reference angle will be 60, right? What is a cosine 60? And what is a sine 60? You should get this one, right? Cosine 120 is going to be quadrant 2, so that's a negative. Quadrant 2 for the sine will be positive. And then we're going to distribute the 256 here. You're going to get negative 128 plus 128i square root of 3. So that will be your final answer. Okay, you could do the same thing. You could use this 1 plus I square root 3. You're gonna multiply by itself 8 times. You're gonna get the same answer. Okay, of course it's gonna be really time consuming. So we will just change to the trigonometric form, apply for the de Moivre's theorem. Nth root. For a positive integer n, the compact number a plus bi is an nth root of the compact number x plus ji. Nth root theorem. If n is any positive integer, r is a positive real number, and theta is in degree, then the non-zero compact number r cosine theta plus I sine theta has exactly n distinct nth roots given by nth root of r and then times cosine alpha plus I sine alpha. Okay, what is your alpha? Alpha talking about the theta plus 360 degree times k and then over n. Okay, or you could separate into two guys. And what is your k? K is talking about from the 0, 1, 2, 3 until n minus 1. Let me explain this guy. Nth root theorem. For example, if I have a compact number z to the power of n equal to r cosine theta plus I sine theta. Okay, and then I want to find out the nth root of this compact number. So what we're gonna do? Okay, let me write one more time first. Now I want to take it to the nth root. Okay, so what I'm gonna do? I'm gonna do the same thing for both sides. So on my left hand side, I cancel out. This is gonna be my compact number n. And this one, that will be the nth root of r. Okay, and then this guy, and then I will have a cosine theta plus I sine theta. Instead of writing the nth root, I'm gonna put 1 over n. Okay, right? Now, I'm gonna apply the de Moivre's theorem. I could distribute the n 1 over n to the theta. So, I'm gonna have this guy. Okay, and that's why you're gonna see the nth root of the r. So you may ask, hey, how come you only have a theta over n, but they do have a theta plus 360 degree times k and then over n? It is because the theta that I represented is only from 0 to 360 degree. Okay, of course there will be more than that. So you could think about it. This is just my theta, the argument. And then when I add 360 degree in the picture, you could emergence looks like that. I have the theta, I have the argument. When I add 360, I do have the coterminal angle, okay? And then I could add one more 360 here. I also get the coterminal angles again. So that's why they will be multiplied by k here. K is talking about when k equal to 0, we are talking about the theta. When k equal to 1, that's talking about you add 1 360, the first coterminal angle. When k equal to 2, you're gonna get the second coterminal angles. Okay, and then over n, this is talking about like this guy when we apply the De Morphis theorem. So when you want to apply the nth root theorem, first you're gonna think about it, the modulus, you're gonna be take the nth root. When you want to apply the nth root theorem, the R, the modulus, you're gonna take the nth root of it. And then for the data, it will become this guy. The k, it depends on your nth here. Let's say I'm looking for the z to the power of 4th. Then my k, that will be equal to 0, 1, 2, and 3. Z to the power of 4th, it means we do have a 4th root. So when k equals 0, you do have the first one, second one, third one, and the 4th one. So you can see the k is always n minus 1 because they're counting for the 0 also. This is talking about when you're working on the degree. But when your statement is talking about in radians, you're going to do the same thing. Your alpha will become theta plus 2 pi. 2 pi is talking about 360 degree, right? Times the k, okay? The first coterminal angle, the second coterminal angle, the third coterminal angle. Same idea. K will be equal to 0 until n minus 1. Okay, let's try to do this example together. Find the 2 square roots of 4i. Write the roots in rectangular form. Okay, square roots. So I'm gonna let z square equal to 4i. Okay, 2 square root. So I put the 2 in here. First, we want to find the 4i in the trigonometric form. Remember the step? 4i means x will be equal to 0, y will be equal to 4. Okay, so that will be on the y-axis. Okay, on the y-axis. So the r is going to be do the same thing, r equal to 4. And then the theta, that will be equal to pi over 2. Okay, right? So my c square will be equal to 4, the r, times cosine pi over 2 plus I sine pi over 2. Now, we're going to take the square root for both sides, okay, to find out what is the modulus. Square root of 4, which is going to be equal to 2. And then we want to find the argument since I'm using the radian. Okay, so I will have this formula. The alpha will be equal to theta over n plus 2 pi k over n. Theta, that will be your argument, which is pi over 2. And then the n, talking about the 2 here, because we are looking for the 2 square root. Okay, so plug it in. Simplify it, this guy, that will be pi over 4 plus the 2 simplify. So pi over 4 plus pi k. We find out the general form of your alpha. Now, we're going to plug in what is your k equal to. Since your n is equal to 2, so k will be equal to 0, k equal to 1. That's it, right? K equal to 0, k equal to 1. That's a 2 of them. Plug it in when k equal to 0. K equal to 0, alpha will be pi over 4. When k equal to 1, you plug in 1 here. So pi over 4 plus pi, which is 5 pi over 4. Okay, now we're going to combine everything together. So I put the 0 here. This is talking about when k is equal to 0. Okay, z0, the r equal to 2 cosine plus I sine theta. Theta will be the first one, pi over 4. Since the answer request will be the rectangular form, so I try to write it out, the whole thing here. So cosine pi over 4 will be square root 2 over 2. Same idea with the sine pi over 4. And then we're going to distribute the 2. So you should get the first answer. Square root 2 plus I square root 2. Second one, we do have 2 CIS 5 pi over 4. Okay, write it out. What is a cosine 5 pi over 4? You should get negative root 2 over 2. And this is going to be root 2 over 2 here. Distribute it. So you're going to get negative root 2 plus I square root 2. Okay, your final answer, that will be the rectangular form. Okay, one more. Find all fourth roots of this complex number. Write the roots in the rectangular form, just like the previous example, and then graph them as a vector in the complex pen. Okay, so all fourth roots. So I'm gonna let z to the power of 4 equal to this complex number. Now I want you guys try convert this into the trigonometric form. Okay, remember the first step, right? First step, think about which quadrant is it. Negative x and then x squared root 3. It should be quadrant 2. Okay, quadrant 2. Find out the R and then find the argument first. Okay, check your work. Find out the R. You should get 16. And then the argument, theta, tangent theta equal to y over x. The reference angle, that will be 60 degrees. Okay? And that will be in the quadrant 2. So your arguments will be 120. Now, write it down in the trigonometric form. So c to the power of 4 equal to 16 CIS 120 degrees. Now, we want to find out the R. We're going to take the fourth root for both sides. So you're going to get the 2 here, the absolute value of the R. And then what is the argument? We're using the degree, so we'll be using this guy. Theta will be 120. The n, which is going to be your 4. Okay? Plug it in. Simplify it. You're going to get your alpha should be 30 degrees plus 90 degrees times k. And then think about it. What is your k equal to? Your n equal to 4, so k will be equal to 0, 1, 2, 3. Okay, 4 of them. So plug it in one by one. So the first one, when k equal to 0, alpha, that will be equal to 30 degrees. K equal to 1, you're gonna get 30 degrees plus 90 degrees times 1, which is 120. Try find out the k equal to 2, k equal to 3. Check your work. You should get 210 and then 300 degrees. Okay. Now, we're going to write it down. Z0. Okay, this 0 means k equal to 0. Okay, we do have the 2 CIS 30 degrees. Write it out because we want to find the rectangular form. Simplify it. So I get the first complex number, Moivre plus I. Second one, 120. You should get -1 plus I squared root 3. Try find out the Z2, Z3. Okay, check your work. And then the Z3 here. Okay, we do have a 4 rectangular form here. And then, go back to the questions. We want to write the root in the rectangular form and then graph them as vectors in the complex plane. Okay, now let's try to graph the complex number together. And I'll be using the polar graph paper. So you're gonna see this is a 15 degree for each part here. So this is gonna be 30 degree. This is a half of it, so 45, 60, and that'll be 90, 180, 270, and then 0 or 360 here. Okay, right? So 15 degree, 15 degree, you could just count it by yourself. Okay, now let's try to graph the first one, the Z0. Okay, you're gonna see the modulus is gonna be 2 cosine 30 plus I sine 30. 2 talking about 2 unit. So I'm gonna do 1 to 2 unit here and 30 degree. So I have the first point here. This is gonna be my Z0. Second one, 120. 120 is gonna be here. This is gonna be 120 degree. And then same idea, 2 unit. 1 to 2 unit. So this point, that will be the Z1. And then 210. 210 should be here, 1 to 2 unit here also. That will be Z2. Okay, this point. Last one, 300. So 270, 300 will be here. 2 unit, 1, 2, same idea. So that will be my Z2, Z3. Okay, so I'm supposed to get the 9 in here. This is my complex number. This is my complex number. This one. And also this one, the last one. Okay, so you could join all the points together to make a circle here. Okay. So this is gonna be my complex number in the complex plane. You could see they're gonna divide the degree equally. Okay, they do have the same modulus. Okay, it's gonna be all 2 here. So look at the picture. It's gonna be looks like this. Okay, right? This is how you guys graph the complex number on the complex plane. Okay, last example. Find all complex number solution of x to the power 5 minus 1 equal to 0. Graph them as vector in the complex plane. Okay, we do have this equation. Now, let's add 1 for both sides. And you could see we only have a one wheel solution. Okay, x equal to 1. But there are 5 complex number solution because n equal to 5. And we try to write ones in the trigonometric form. So think about it, x to the power 5, that's equal to 1 plus 0i. So x equal to 1, y equal to 0. Okay, so on the rectangular plan, it should be on the x-axis. So you know r equal to 1. What is your theta? What is your argument? It should be equal to 0 degree, right? Then x to the power of 5th equal to 1 times cosine 0 degree plus I sine 0 degree. And then we're gonna take the 5th root for both sides. So the r still equal to 1. How about the argument? Argument, the alpha will be theta over n plus 360 degree times k over n. Theta, that is equal to 0. N, that will be equal to 5. Plug it in. You're gonna get 72 degree times k. Okay, so this is the alpha. And then we plug it in. What is your k equal to? Make sure you guys write it down. What is your k? K will be equal to 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. So you do have a 5 root. Plug it in. When k equal to 0, alpha is going to be equal to 0. K equal to 1, we do have a 72. Okay, try find k equal to 2, k equal to 3, and k equal to 4. So you should get alpha equal to 144, 216, and 288 degree. Okay, so my 5 root is gonna be z0 equal to cis. My r is gonna be equal to 1. Okay, cis 0 degree. Second one, cis 72 degree. Okay, same thing. This question, they didn't require your final answer is in the rectangular form, so you could just keep your polar form. After that, you're gonna try to graph this complex number on the complex pen. So try to get the polar graph paper and graph it. You should get your work like this. And one more time, you could see these 5 complex number should be shared the 360 degree equally. Okay, 72, 72, 72, 72, and 72 degree. That's it.